Dear friends, in this video I will be explaining about the projections of solids when the solids are inclined to both the planes, that is horizontal and vertical plane, and also to demonstrate using 3D AutoCAD models and drawing the projections of solids in AutoCAD. Let us first see the procedure of projections of solids when the solids are inclined to both the planes. First of all, we need to position the solid between the planes of projection. After positioning the solid, we need to start with a view 1 where the solid base is parallel to the plane of projection. Usually it gives the true shape. In order to start the view 1, we need to first observe whether the base of the solid is parallel to which plane, whether it is horizontal plane or vertical plane. If the base of the solid is parallel to horizontal plane, the parallel horizontal plane can be seen in a top view, so we will start from the top view. If the base of the solid is parallel to vertical plane, as the base is parallel to vertical plane and the vertical plane can be seen in the front view, so you will start with the front view. In that way, we will start with view 1 based on the solid's base is parallel to the plane of projection. When the solid is inclined to both the planes, we need to see the edge or the corner or something is resting on horizontal plane or vertical plane. We need to see accordingly, we need to imagine the base of the solid is parallel to which plane. When the edge or base is not resting on any plane, we can take a convenient plane to which the base is parallel. Sometimes if you make the base parallel to horizontal plane, it is convenient to draw the projections. Some other times, if the base is parallel to vertical plane, it will be convenient to draw the projections. In that case, we can take any one plane. Usually, when the base edge or the base corner or the plane or anything, when it is resting on any one plane, usually we need to see the base is parallel to which plane, then accordingly we can draw the view 1. Once the view 1 is drawn, we can draw the view 2. We can project view 2 from view 1. Then we can rotate the view 2 with the specified angle. They will be giving some specified angle with respect to the plane. It is the view 1 is resting, and accordingly view 2 can be rotated, and then after rotation that becomes the view 3, and here if you observe, this becomes the view 3, and in the third step we got view 2. Then we will go to view 4, and view 4 we will get when we project from view 3 and view 1, and this will become view 4. And if you rotate view 4 with a specified angle or given angle, so you will get view 5. Finally, we will project view 6 from view 5 and view 3, and we will also add the hidden lines. Not only in this step 6 and even step 4 also, we need to add if the hidden lines are there. In this video, I will also explain the hidden lines concept, how to identify the hidden lines. Let us start the projections of solids when the solids are inclined to both the planes by taking one example. Here I am taking this example without the dimensions, only for you to get idea to draw the projections of solids. A square prism base edge is resting on horizontal plane. Here the base edge and the height I have not mentioned, approximately 30 mm base edge and height is 50 mm, I will assume. The axis of the prism making 30 degrees to horizontal plane and 60 degrees to vertical plane. Draw its projections. Now if you see imagine the square prism and its base edge is resting on horizontal plane. When the base edge is resting on horizontal plane, we can easily make the base parallel to horizontal plane. It is not so easy to make the base parallel to vertical plane. So because again we need to bring the base edge resting on horizontal plane. So it is more convenient to make the base parallel to horizontal plane. And then we can go to 30 degrees angle to horizontal plane after you rotate the view 2, and then we can rotate 60 degrees to vertical plane to the other view, so that we can able to get the final view. So let us see how to draw these projections. Now first any projection you wanted to draw, first we need to draw xy line. This is the intersection of horizontal and vertical plane. Now because the prism is resting on horizontal plane, I will first draw the base of the prism, square prism. So this is the base of the square prism. I am assuming that A, B, C, D are the bottom base, 1, 2, 3, 4 are the top base. The square prism consisting 8 corners. So these are the 8 corners, A, B, C, 1, 2, 3, 4. Then I need to, this is the view 1. To get the view 2, so view 1 will be below xy line, so view 2 will be above xy line, so in the front view. So that I will get by projecting A, B, C, D and 1, 2, 3 into the above xy line. As it is resting onto the horizontal plane, so I will be marking A, B, C, D on xy line because it is resting on horizontal plane. I am assuming that A, B, C, D are the bottom base and 1, 2, 3, 4 are the top base. So this will be the front view, and here it represents the height, and there will be axis also. I am avoiding axis in order to avoid the confusion in this the demonstration, only for this example. Now I got the front view. This is the top view. So the top view is actually the view 1 and the front view is the view 2. So I first start with the view 1. I got the view 2, and when this solid is making 30 degrees angle with the horizontal plane, so let us say this is the 30 degrees approximately. So when the true angle you can able to see in the front view, the shape will not change. So when you are rotating this, the shape will not change when you are rotating with the true angle, that is with the horizontal plane. When we see something is making angle with the horizontal plane in the front view, so that I can able to see with the true angle and the shape will not change. So this view 2 will be rotated with the specified angle, that is 30 degrees. Now I will also mark this all A, B, C, D on this solid. So this is A dash, B dash, because in the front view I will be giving the notations as A dash, B dash, C dash, D dash, 1 dash, 2 dash, 3 dash, 4 dash, and if it is in the top view I will be marking A, B, C, D, 1, 2, 3, 4. Now I need to, this is the view 3, and to get view 4 I need to draw the projections from each and every point to the below xy line, and also this is the A dash projection, B dash projection also, this is C dash, D dash projection, 1 dash, 2 dash projection, 3 dash, 4 dash projection. The same manner I will draw another projection line from the top view A, B, C, D and 1, 2, 3, 4. If I draw the projections, so this becomes A dash and A, here it is coinciding, so this becomes the top view A, and B dash and B is coinciding at this point, so this becomes a B. C dash and C is coinciding here, this becomes C. D dash and D is coinciding here, it becomes a D. And likewise I will mark all the points here. Once after I mark all the points, this becomes the top view, that is the view 4. Now according to the problem, this solid is also making some angle with the vertical plane. When the angle is making with the vertical plane and this true angle we can able to see in the top view. So here now this axis is making the zero angle with the vertical plane. So axis, let us say here, and the axis is parallel to this edge, or otherwise the axis, we can say axis is parallel to xy line. So it is 0, so it is parallel. Now I need to make the angle with the given specified angle. So I rotate the axis in such a way that it will make a 30 degrees angle with the specified angle. Then this becomes the view file. This becomes the view file. So now this is the view file. So now finally I need to get view 6, that is the final view. To get view 6, I need to project each and every point A, B, C, D and 1, 2, 3, 4 above xy line. Again from the view 3, I will draw horizontal projections to intersect these vertical projections. If I make that, I can able to get the points. Now for example, this is 1 dash, so these two are intersecting here, this becomes a 1 dash. This is the 2 and this is the 2 dash, so this becomes a 2 dash. This is the 4 and this is the projection of 4 dash. 3 and this 3, so these two are intersecting here, this becomes a 3 dash. Likewise 1, 2, 3 and ABCD also, if I project, the ABCD will come here. So A and A is getting projected here, this becomes a B, C and D. Now how to connect this all A, B, C, D and 1, 2, 3? And if you carefully observe, I need to first draw an imaginary line in order to identify the hidden lines. Now we are seeing the front view. When you see the front view, so from this is the top view, when you are seeing the front view from this side, and all these edges will be visible. That means if you draw an imaginary line joining from leftmost corner to rightmost corner, the edges below to this line will all visible in the front view. So because we are seeing from here, from this side, so all these edges will be visible. So that means A, B, C will be visible and C2, 2, 3, 3, 4 will be visible. So all these edges will be visible. So let us join one by one. So A to B is visible. So draw A to B, B to C and B to C also visible. And then C to 3 is visible, C to 3 is visible, 2 to 3 is also visible, 2 to 3 you will be visible. So you will be joining. And after that, you need to close all the outside lines. So let us say this is the projection of the final solid. No hidden lines appears at the outside boundary. So because when the outside is there, even though it is above this line, but still because it is the outermost edge boundary, so you can able to see in the view. So we need to close the outside lines. So if you take the outside lines, so here the A dash 1 dash, A dash 1 dash, actually it is above this imaginary line, but A dash 1 dash, because it is the outside lines, I will make it dark line, because outside no hidden line will be visible. And 1 to 2, half of the line is above this imaginary line and half of the line is below the imaginary line, but still it is outside the boundary, so I will be making dark. And with that I can able to, and B to 2, that is B to 2 is below this line only, so it will be visible. B to C is visible, so we already draw this. And 2 to 3 is visible, so you completed all these lines. So that means the solid actually it will visible like this. And what are the invisible lines? Now I completed all the outside boundary lines with the solid line, and I also completed the dark line with all the edges which are below to this imaginary line, which I consider from A to 3. And now I need to identify the hidden lines. To identify the hidden lines, I will be first seeing the edges. So this is the D4. D4 is the one of the hidden line. So D to 4 is the hidden line, and 4 to 2 and one more 2 4 to 3. So this is the another hidden line, and you can see which is above this line. 3 to 4 is above this line, D to 4 is above this line, and likewise if you see, so now you can draw the 3 to 4 is above this line, and 1 to 4 also above this line, 1 to 4. So you can make this 1 to 4 also hidden line, and 4 to D also hidden line. It is not visible. So these all lines you can able to mark it as hidden lines. Hidden lines will be marked with dashed lines. So with that, the projection of these solids and identifying the hidden lines are also over, and this becomes view 6. So with this, the projections of this entire solid is over. So only thing is we need to start with the view 1. So where to start with view 1? We need to see and properly start with the view 1. If you make a mistake with view 1 with the wrong the plane, so automatically remaining all things will be wrong. So you need to start with the correct view 1 in the correct place, whether it is below xy line or above xy line. Then simply you project it to other side of the axis, then you will get the view 2, and rotate this view 2 and you will get view 3, and view 3 if you project you will get view 4. If you rotate view 4 you will get a view 5, and if you project view 5 and view 3 you will get a view 6. I also explained how to identify the hidden lines. With that, if you draw, we will be able to identify the hidden lines and we can able to complete. So there are two types of cases in these projections of solids when they are inclined to both the planes. The case 1 is you will be starting the view 1 in the top view, so that the view 2 will be in the front view, and view 3 also in the front view, because this view only we are rotating, and view 4 we will get projection from view 3 and view 1, and view 4, that is we will rotate and we will get view 5, and finally we will get the view 6 at the above xy line. So you started with below xy line, final view you will get above xy line. So this is the case 1, and the case 2 is you will start the first view 1 in the front view, then you will get the view 2 in the below the xy line, and you will rotate the view 2 here, and then you will get view 4 when you are doing projection from view 3 and view 1, and rotate the view 4 you will get view 4 5, and from projecting view 5 and view 3 you will get view 6. So here view 1 you started with above xy line, that is front view, finally you got it the top view. So that is how we can able to see the case. So first identify whether your problem is belongs to case 1 or case 2. So now let us try to solve the problems in the worksheet. A square pyramid, base 30 mm, height 50 mm, is resting on its base edge on the ground. The axis of the pyramid makes 30 degrees to HP and 60 degrees to VP. Draw projections. Now I need to draw the projections. First of all, I need to identify the base edge is resting on the ground. That means I can make the base of the prism or pyramid parallel to horizontal plane. So if I see the 3D view, so this is how the 3D view in the first stage. So it will be looking like. So base will be resting on horizontal plane, and when the base is resting, the base edge also will be resting. So I am assuming not this side edge, other side of the edge I will be assuming here. So then, and it is making 30 degrees angle to horizontal plane. So if I make the same, the solid rotating, the axis is now making 90 degrees with the horizontal plane, I will rotate such that it will make the axis will make 30 degrees to horizontal plane. Now this is the second stage of the problem. Then in the third stage, and I need to rotate this axis in such a way that this axis will make 60 degrees angle with the vertical plane. Now it is parallel to vertical plane. The axis is parallel to vertical plane. I need to rotate this axis with a vertical plane such that it will make 60 degrees angle with the vertical plane. Now I will rotate. So this is the final position of the solid. So in this final position of the solid, I need to draw the projections. So in this view, you can't draw front view and top view. So you need to start with the first stage only. So that means you need to go back from this stage to back again 60 degrees, making 30 degrees inclination with the horizontal plane. And now this is the first stage. So in this first stage, you need to start with the view. So now the base is parallel to horizontal plane. So you need to start with the top view. So in the top view, you can able to see the true shape of the base. So you will be starting with the top view. So now let me demonstrate the views of this solid in these three stages. Now this is the first stage where I am imagining, this is actually final stage of the solid, but in this final stage I can't directly draw the front view and top view of this solid. So I rotate and I will imagine that the axis is making 60 degrees with the vertical plane, but I will make parallel to vertical plane. So then I will get this the position of this solid. Then even in this stage I can't draw the front view and top view of the solid. So I will also again assume that this base is parallel to horizontal plane. So this will become the first simple position. So now I need to draw the front view and top view of this, and then I need to go to this step by rotating the front view. Then again I will get the view 3 and view 4. Then afterwards I will rotate this in such a way that I will get the view 5 and view 6. So now with these three solids, I will now assume I will take parallel plane of projection. I will go to front view first, or otherwise I will first start with the top view. So if I see the top view, you identify, see here. So the top view of first stage, I can only see the base of the solid and with the apex. So I can say A, B, C, D, and O is the apex. And by projecting, this is the view 1. Then view 2 you will get above XY line by projecting from here, and then you will be getting this after projecting from view 2 and view 3 and view 1. And then when you are rotating, this axis is parallel to vertical plane. Now when you are rotating this the solid, making the axis 60 degrees with the vertical plane, at that time you observe this shape and this shape is same with the same dimensions. Only thing is axis is making some other angle, inclination. So that is the only difference. So that is why, so rotating this the top view will not make any difference in the shape, only the axis angle will change. So now this is the top view. Let me go back to the isometric view, and this is the isometric view, and then I will go to the front view. So if I go to the front view, so this is the front view. So this first the view 2 I will get by projecting from view 1, and after you get view 1, view 2, this view 2 I need to simply rotate with the given angle 30 degrees, such that this will become a final view 3. Then final view 6 you will get it once after you project from this and as well as from view 5. So but here if you identify this apex height and this apex height both are at the same, because this angle you are not changing in the view in the third stage. This angle we are keeping constant, but only the angle with the vertical plane you are changing. So because of that, so this apex you are moving towards the observer. That is why you can able to see this apex as well as this base triangle also, base edge also you can able to see, and this also you can able to see. This shape has been changed here now. It is earlier the triangle is different, now this triangle shape is different because the front view is changing here. But only thing is the height from the horizontal plane or xy line in this front view is same. Apex height is same and this height is same because we are drawing the horizontal projections here. So with that we can able to draw. So likewise we can able to imagine easily when you are rotating this the actual solid, how the shape of the solid is changing in the each view. So now let me draw this projections in AutoCAD. I will go to my documents where I am saving all the files. Then I will open template. After I open template, I will get this template. So now I change the template size because in the projections of solids, so sometimes I need more space. So this template I changed to another dimensions, so that it will not consume much space. So here I made this is 90, 60 and 50 distance, and the remaining I have made like this. So here even if you see, I will go to draft and annotation. So if you see these dimensions, maybe it is approximately around the 34 is there. So I made approximately some distance so that I can able to accommodate everything. So these dimensions I am giving. If you want to change the layout, you can change this layout to these dimensions. And with this, what is the advantage? So it will have the lot of space here and projections of solids will be easy. So as I also earlier mentioned, I am also mentioning a separate color coding for the top view, front view, hidden line, axis line and projection lines. And I also use these notations because if I use these notations, it will be very useful for drafting. So now let me draw the first problem. So this one single problem also I kept in a layout so that it will be easy for me to use the xy line and the question number, etc. Otherwise every time I need to draw. So now I am comfortably I am taking at the middle because more than one problem I can't solve in one sheet. So I am taking. So now I need to start with the top view. Now this is not the front view height, so I just delete this. So these things I will delete. The dimensions also I can delete. So let me first start with the top view. So now according to the problem, the top view I need to draw below xy line. So xy line I will move. So I need 3 stages problem. So I will keep xy line till here. So I will on ortho. So till this place I can use extend line up to here. So now I am also using the line weight. So I will close this the command bar, and I will make some distance below, so that it will be convenient. So I don't want this distance, otherwise I can easily draw a square with 30 by 30 and then I draw. So this becomes A, B, C, D and this becomes the apex. So now this is the another projection line till here. So now this is the projection line. So let me draw a projection line from the apex to center. Now I need to draw the axis height. Axis height is the 50 mm. So take a line command. So draw a vertical line which is 50. Then you draw horizontal this inclined line. Then you can move this apex this becomes the front view, so this becomes the top view. So give the dimensions at the spot, so that again you need not to worry. So this is the dimensions you will give on the same line. So now we got the front view, and now you wanted to if you want, you know, the change the properties here itself, you can do it, or otherwise in order to minimize the time you will be making the properties at the end. So copy this front view, copy and paste here somewhere at your convenience, convenient distance. Now this edge DC, I am assuming that this is resting on horizontal plane. So then I will be rotating this and making the base angle this one. So now this is making some 30 degrees angle with the horizontal plane. So that means it is making 90 degrees. So I need to rotate minus 60 degrees. I don't want this much space here, so I can just move. I can move such that the space can be minimized. Then I will draw the projections. So I will draw the projection lines from A and B. I draw the projection line. D and C, I will draw projection line up to apex. Here I need to draw another projection line. So again horizontal projections I will draw up to D and C up to here, and B and C up to here, and up to apex I need to draw the projection here. Now I need to draw the projections, or I need to draw the view. So this is a view 3 is over, and view 4 I am drawing. So I will take a line command, and now I will A and B above this line, so it will be visible, A, B, and O, apex with apex. So I can off ortho, and with apex I can able to see. And again from DO, it is outside actually, DO. So I can able to see the DO because it is outside. So I will make it dark line. And there is a CO also, it is outside the boundary, so I will make it dark line. Then there is only one line which is DC, which is below this line. So here, in order to identify the hidden lines, I will be considering the leftmost corner and rightmost corner. I will try to draw a line. The portion, above portion of this line will be visible. That means the ABO will be visible, and the remaining things will not be visible which are below to this line. But DC and CO will not be visible according to that rule. But as those lines are outside this the solid, so that will be with the solid line. So now only DC and D to C is invisible. So I will be trimming this line because I need to make this invisible line. So I will be drawing a line which is invisible. Now I will make the solids here. So now I will do the match properties. So match properties. So this is the top view. So I will make all these lines top view. This is also top view, and this edge is top view. So this all projection line. So now I can match properties. This is the projection line. All these 3 lines are projection lines. These 3 lines also projection lines. Then I can draw another line from here to here, which is the top view. So again match properties, this place to this. Yes. Now I need to do match properties. This is the hidden line, and here this is the axis. So axis also I need to do, match properties, do match properties. So in order to avoid this axis, I will trim this. So match properties. So where is the axis line? The axis line is here. So this is the axis line. Here is the axis line. So here I did not draw the axis line. So it should be actually from the center, but I will draw axis line till here. So properties you match, and this is the hidden line. Match the properties of hidden line. This is the hidden line. So this should be a hidden line. So I match the properties for that. Now I need to, now this is the front view. I need to match properties of the front view. This is the front view properties, front view, and this is the front view lines. So this now let me give this angle also. Angle is 30 degrees. I will go to the measuring angle. I will select these two and I will mention this is 30 degrees. So without the intersecting the solid line, you can give the dimensions. Now this is the solid, and now with this you completed view 4, but I need to give the notations. When you are giving the notations also, so you need to give the notations in such a way that it should not touch the projection lines or the solid line. So likewise you need to give the projection, you need to mention the notations. Now here if you give the notation, this becomes A, B, C, D. So now I will be copying A, B, C, D are here only. So I will copy this A and B. So I will paste here, and C and D I will paste here again. This two here this side, and apex O is here. I will copy and I will keep the apex here. So with this I could able to complete the view 4. Now view 5 I will get when I rotate this, and there are two ways to rotate. If I rotate this in such a way that this apex is away from XY line, so the apex will come here, and the way it appears will be different. So and if suppose if I make the apex towards the XY line, then I can able to see the base, and apex I can't see, and this all will become hidden lines. But anyhow I actually imagine that the apex is away from XY line, that means towards the observer. So now I will be copying this, the view 5, sorry view 3, view 4 I am copying, and this view I will be keeping here. So I will keep here, and now how I wanted to rotate I can decide, and now this axis is parallel to XY line. Now I need to make in such a way that this should make 60 degrees. I can rotate clockwise, or I can even rotate anti-clockwise, but I prefer rotating the solid in clockwise. So I will be rotating this in the clockwise direction, that means this way. So I will be rotating with -60. Now I will be making little convenient distance so away from the XY line, so that the many lines will not be coinciding. So now I need to draw the projection lines to get the final, the front view. So draw the projection line with the line A, from A, starting from A. So you take ortho you on. Where is A? A is here. So you can also draw horizontal projections first. So because only 3 lines, this A and B, and this is apex, and then C, D and E already there on XY line. So now I will be projecting from A to till this projection line, and B also till this projection line, because A and B are here, and C and D up to XY line only. This is the C and this is the D. This is up to XY line, and apex is till here. So apex you should start from here, and apex is here. Okay, apex is here. Now I need to identify the points. Now I will trim these extra lines so that I can able to avoid the confusion. Now these all are imaginary lines. I can match the properties with this red line. So these all are imaginary lines. Now even now, because now I give the projection line, so this A is intersecting, so I will just rotate or move in some other direction so that it will not intersect the projection line. So this becomes a. So this is again where is the axis? The axis is here. So axis, base of the axis is here. So that also you can draw. So the base of the axis is somewhere here. and here, and this center you don't know, so that is why you can draw another imaginary line from here. So from this base center you can draw vertical line. So this is the base center. So then you can even delete this. So now these two also a projection lines. So this we draw in order to locate the center of the base in order to draw the axis. Now we need to identify the A dash, B dash, C dash, D dash. So let me just copy A dash, B dash, C dash from here. So now A dash, where is A dash? So A dash, now I will off ortho when I give the notation. So A dash and A. So the A will be here somewhere. So you can, it is preferable to draw the first, draw the lines and then you give the notations, otherwise it may intersect, but we should know. So that is why we just keep here, and this is the B and the next one is B. So I will copy B, and B will be on the same line, and from here it is projected, so I will be keeping the B here, so somewhere here. And A, B, C, D. C is here, the projecting from C here, so I will take the C from here. So this becomes a C, and the D will be here. This is the D. So all base points I received, and finally apex will be somewhere here. So now I need to join. So how I can join? Now I need to consider, there is one rule that I need to consider the leftmost point to rightmost corner point. So this, if I join, whatever I can see below the XY, because it is in the top view. So if I am seeing the front view from this side, I am seeing the front view from this side. So if I join leftmost corner, that is B, to rightmost corner O, so the line joining will be this, and BO. Below this there is only one triangle, that is a BCO and B. So this is visible, so you can make that line, corresponding line, darker. So that means the B to C, so B to C, C to O, and O to B. So this is visible, so this you can make it dark. Then the other rule is all the outside corners, all the outside lines will be visible. That means now A, B, C, D are the base, A, B, C, D are the base. So but here if you see D to O is outside, so you can make this line dark, DO, even though the DO is above this line, so still it is visible. And CD, it is 50% this side and 50% that side, but CD is actually the outside, so this can be visible. So all outside lines are I made dark. So now let me make the match properties, so it will visible the very good. So this is the front view, this is the front view, this is the final front view which I can able to see. Now how to identify the hidden lines? Now to identify the hidden lines, so you need to identify the edges which are above. So A and D, these are actually above this line, and AB also above this line, AO also above this line. So these three lines are invisible lines, so we need to draw these invisible lines now. So now you can trim this line also, because it will hide the hidden line. So now I will be drawing a solid line first, and then I will do the match properties. So and A to D, A to B, and A to O, these three are the hidden lines which are other side of the solid. So these are the hidden lines, so I will be match properties with the blue line which is hidden. So with this I can able to complete the solids and the final view, that is view 5. So this will become the solution for the question 1. So I can save this. In the worksheet we will solve problem number 4. Write circular cylinder diameter 40 mm, height 50 mm is resting on a point of its base circumference on the ground. Its axis is inclined 45 degrees to horizontal plane and 30 degrees to vertical plane. Draw projections of the cylinder. So here we need to first position the solid with respect to horizontal and vertical plane. If you imagine, this is a vertical plane and this is the horizontal plane. The cylinder is resting like this, and actually, as per the according to the problem, a point of its base circumference, on the base circumference any one point is resting. I am assuming that there is another point which is resting at the right side. Then I need to make the axis 45 degrees angle to horizontal plane. So if I make the solid incline, and it will be resting on its circumference on the horizontal plane. Now I need to make the axis, now axis is parallel to vertical plane. I need to rotate in such a way that the axis will make 30 degrees angle with vertical plane. So this will be the final, the position of the solid. So now I need to go back to the, this is the third stage of problem, and this is the second stage, and this will become the first stage. So now I need to draw the projections. So first of all, I need to identify which view I need to start with. So because the base is parallel to horizontal plane, I need to start with the top view, and then the front view, and the view 2, view 3, v4 and v5 and v6 simultaneously will get it. Let us try to see how the front view and top view of these solids in this position will appear in front view and top view. And this is the first stage of our the solid, and in the second stage this solid is making, axis is making 45 degrees angle with horizontal plane by keeping the base corner or on the point on the circumference resting on horizontal plane. And in the final position, this same solid is making 30 degrees angle with the vertical plane. So in this position, let me see the top view first, because I need to draw the top view here. So if I see the top view of these solids, so the top view will appear like this. So the first stage, it is a true shape of the base, so a circle, and this is the view 1, and the view 2 you will get above xy line, and again you will rotate, and finally you will get this, the view 4, and this view 4 you are rotating this base this side in such a way that, so this will become the view 5, and a view 6 you will get it by projecting the points from each point on this circumference. So now if you see the isometric view again, and this is the isometric view, and if I see the front view is appearing like this. The front view of these solids are appearing like this. So here the first the front view is appearing like a cylinder, like a rectangle. After we rotate, so it will make the required inclination 45 degrees. Then this will be the final the front view. So let us try to draw the same thing in AutoCAD. So now this is the projections of solids inclined to both the planes. So let me save the drawing, the save as projections of solids, the part 2, save. So now I have completed the first one here, and now I need to do the fourth problem. So I will copy this layout, entire layout, then I will delete whatever is not required. So this much is not required, I will delete, and then I required only the top view which is cylinder, so I will delete this also. I will delete everything, because there is a side by, there is one more diagram, so I can easily draw. So because it is a cylinder, it may also take some more space, so I will move this. I will on ortho, I will extend the line, and xy line I will keep at center. Now let me draw the top view. So now this is a cylinder having a diameter 40 mm. So I will take a circle. I will go to the drafting and annotation. I will take a circle. The circle radius is 20 mm. The diameter is 40 mm. So to make it convenient, I will move away from this. So then the front view will be sufficient. Then I need to consider the generators on the circumference. So how many generators I need to consider on the circumference? So some people, they will consider 12 generators, and the minimum we need to consider 8 generators in AutoCAD when the solid is inclined to both the planes. And if the solid is inclined to only one plane, only 4 points are sufficient. Now to identify the 8 divisions on this circumference, I need to first divide this circumference into 8 equal divisions. So you can use a divide command. Divide, enter, and select the object to divide. This is the object I need to divide, and the number of segments are 8. Once after I say 8, there are 8 points are visible here, and these points sometimes may not be visible for you because this I put in the point mode. So if you go to PD mode, and if the PD mode is 3, then only it will be visible. If the PD mode is 1, these points will not be visible. So make PD mode as 3, and later when we are taking a printout, you can off PD mode. So as of now, I will on this. So now I am not drawing the generator. Some people, they will draw the lines like this, but here in AutoCAD we don't need to draw all the lines because it is already visible here. So now I will draw the front view. So draw the projections. So the projection line till here, and the height is 50 mm, and here also the height is 50 mm. So I can close the cylinder. Now I draw the projection lines here. This is another projection line. The generator, actually this is another generator. So I will better I will draw the projection line till here, and this is the axis, and this is the projection line till here, and this is the generator. So this is the projection line till here, and then it is generator. So likewise I can draw. So I need to give the notations here. Now I will start with A, B, C, D, E, F. So I will take the notations from here. So these all notations will help you now, because these all notations A comma 1, so both are at same place. So I can just move one by one notation. Here this is the A comma 1, because the top base I am considering 1 2 3, and bottom base I am considering A B C D. So both are coinciding at these points. So then I am keeping both at a time. So it will minimize a lot of your time, because in AutoCAD when you want to draw the projections of solids in AutoCAD, it will take a lot of time for giving the notations itself, identifying the notations and marking the notations. So if you use this, it will minimize the overall time for giving the notations. So here this will be the another. So now for the top view is over. Now let me draw the front view. So if I draw the front view, the front view notations I will get again here, because this all should be with the dash with the front view. So I will take these notations here. I will keep at the center because it will become convenient for me. So here now, oh no, it is actually a dash and 1 dash is not at one place. So I will try to take this other notations, because this will help me separating this the top base and bottom base. Now the bottom base I am considering down. So I will move the A B C D here. So this becomes a dash, this point, because this B and H also. So this becomes a B is here, and if you want to make H dash also here, and again you go to C dash, the C dash is here, You can check here C dash and G dash also. G dash also here. And then D dash here and E dash, F dash also. F dash. And finally this is the E dash. So this is the top base, bottom base and the top base. Now I will move 1 dash here, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash and 8 dash. So apex I am not using for axis, so delete. So like this you can give, if you divide this circumference into 12 divisions, and some more notations will come and it will sometimes make the disturbance. So now let me give the properties, change the properties. This is the top view. I will change the properties like this, and it is the front view. The front view I will the mark only the outside generators. I will make it dark. So here the base, I need to draw one more line, the base. So then this is the axis, and I will first mark the projection lines. So these are the projection lines, and this is the axis. So I will actually mark the axis. So this is the axis of the cylinder. These are the generators. So generators also I am marking here like the projection lines only, these two generators, because those generators I can't see. It is only for imaginary. So that is why I just keep in the same projection lines. So now this is the front view of the cylinder, and this is the top view. Now I need to rotate the front view in such a way that it will become view 3, and it should make 45 degrees angle with the vertical plane, with the horizontal plane. So now I need to on ortho. So on ortho I will keep some distance here. Now I will rotate. So I am rotating this to 45 degrees angle, that is clockwise. I need to give minus 45. So now I will rotate little this side in order to minimize the total distance. So because here I need to draw one more front view, so it will become this much is sufficient maybe. So now I got the view 5, view 3, view 1, view 2, view 3. This is the front view, and now I need to get view 4 by projecting each point. Now I will draw first what I will do. So when I also given an example that if I join the leftmost corner with the rightmost corner, so the joining line, the above all edges will be visible. So in the top view, so this all the edges or the base, top base will be visible in the top view, and in the bottom base, so only some of the things will be visible. So to identify that, what I will do, first I will draw horizontal projection lines, because the horizontal projection lines are the small in projection lines. So only 5 lines will come. 5 lines will come. So these are a number of lines are less, so I will draw first. Then I will be drawing the projection lines here. Now I need to draw the projection from the top base 5 dash to 5. So now I will draw vertical projection lines 5 dash to 5. So where is 5? 5 is here, so I will draw here. And 4 dash to 4, 4 dash to 4, 4 is here. I will draw till here. Then the 3 dash to 3, so 3 dash to 3, so 3 is here. And 2 dash to 2, 2 dash to 2, and 1 dash to 1, 1 dash to 1, so 1 dash is here. So if you identify the points, these are the points. So wherever there is an intersection points, you can use a point command, point, and you can make a point. Here is 1 point, second point, third point, fourth point, fifth point, like that. If you mark, sorry, this is here and here. So this point you can, this points is visible because we change the point mode. So now if you see this all points, so here also one more point will be there. So this all points, it appears like an ellipse. So this is the top base. So better I will draw an ellipse here by taking ellipse command, and ellipse command I will take axis ellipse. So I will select this major axis and then the minor axis. So even other points also are joining with this ellipse. So this is the top base, and now let me join the bottom base. So to get the bottom base, again I need to draw the projections. So here, so whatever the extra projection lines, that I will try to trim it. So this all not required. So in order to avoid confusion, so I will trim these lines so that, so these points are visible. So other things I need not to trim because it is actually, so this I am not trimming because this point, it is also 7 dash also coming here, and the 3 dash also coming on the same line. So now let me identify the bottom base. So again I will draw the projections from A dash to A, and E dash to E, and C dash to C, and B dash to B, and D dash to D, up to D, and identify the points. I will use point command. So here is the point, second point, third point, fourth point, fifth point. Likewise I can identify. So now I need to draw another ellipse. So ellipse command again, I will use the ellipse command. I will go to ellipse, sorry, ellipse, axis ellipse, take the major axis and then the minor axis. So now this is the bottom base. Now I need to change the properties of this. Now if I identify the top base is visible, so I will make the mark the top base as a visible. So I will make with the solid line. Then I can also see this base is also visible. So before that, actually if I give the notations, it is actually correct. So let me give the notations for all this top base and bottom base. So if I copy the notations again, 1 2 3 A B C D and 1 2 3. So here are the notations. So I will copy these notations. So when I give the notation, I will off the ortho. So now this is the bottom base, the top base. I will give first the 1 dash to 1. This becomes a 1. So move this 1 till here, and 2, the 2 is here, 3, 4, I will move here. So it is very easy if I draw this type of the text well before. 7 and 8. Let I will keep all the notations outside. And now A B C D I will give here. This is A, sorry, this is A. So sometimes if you click on the text, so sometimes it will go away because if a nearest point is there somewhere, so that is why I will make the copy here like this. So now I want to the copy C I will copy like this, and D I will select, and base point I will take little away. That way I can avoid coinciding these things exactly with anyone. E, F and G, H. This is a G and it is a H. So if you want to exactly move, so you can move also. This is sometimes if you use this way, it is the one adjustment we need to make it. So now this is the top base which is visible. I made it color, and I also make the color because this outside lines are visible. All outside lines will be visible. So I will make the match properties with this. So this outside line is visible, this outside line also visible. Then half of this circle, now you see this bottom base is not visible. So but outside the boundaries will be visible. So half of this ellipse will be visible and the remaining half is not visible. So what I do, I will trim this ellipse, half of the portion, and again I will do mirror so that it will not become a single ellipse. So then I will change the properties. Outside this line is visible because it is at the boundary, but this remaining half of the ellipse will not be visible because that will be other side of the ellipse, other side of the solid. So that I need to match the properties with the hidden line. So the hidden line is like a blue color line, so I will match the properties with this. So now the axis also will come here, so I will also draw an axis from here to here, the center point of the axis from here to here. So I will draw a line from here to here. So that I will what I do, I will also trim this line in order to avoid this line coincide with the other line. So I will match the properties with the axis line. This is the axis line. Okay, so with this it is completed, but only thing is I will match the properties. All the projection lines should be in red color, so I will make all these lines red color. I will make all these lines red color. Now this is the fourth view where we can only see this, the top base and the bottom base. Half of the bottom base we can't see, but only the curved surface we can see. This is the curved surface actually. So if you see this curved surface, we are seeing this bottom base not at all we are seeing, but when we are seeing from the top, half of the base from the which is coincide with the curved surface will be visible. So that is how we can able to see. Now I need to copy this, the top view, so without the projection line. So I will use copy command. So take this, the top view, copy, and I will on ortho here. I will on ortho, so I will paste here. So now according to the problem, this now this solid is making 30 degrees angle with vertical plane. So now this axis, if you observe, the axis is parallel to XY line. Now according to the problem, this is making 30 degrees angle, so I need to rotate this. So I will use rotate command. So I will rotate it. I will rotate it to 30 degrees. So clockwise 30 degrees. So like this. So now this will become the fifth view, and that is the final top view. Now I need to draw the final front view, that is the view 6. So this view 6 to draw, I will draw the projections. Again I will draw the projection lines on the top base and bottom base, and from each and every point I need to draw. So initially what I do, so when I do the, now if I want to identify the leftmost corner and rightmost corner, it is very difficult for the cylinder, but almost we can able to see these edges are visible in the front view. These edges will be visible in the front view. So if I see I will first draw the top base, which is 1 2 3 4, and that I will project. So that way it will be easy. So now I will draw the projections. So now let me move this in such a way that everything I will not zoom in and zoom out every time. So now this is the this is how I will keep. Now I will draw the projections. So take a line command, draw the projections horizontally. So these are the first the 4 major lines. So that means this is from 1, so I will intersect till 1, and from 3 I will draw the projection, and 3 is middle line, so till here I will draw the projection, and this is from 5, so up to 5 I will project. This another line is from 7, and this 7 is at the middle, so here I will draw projection. So now I can trim the lines, because this way I can minimize the number of intersections, and I can minimize the avoiding confusion with the points. So now let me also mark the points. Now this is 1, and 3 and 3 is intersecting here. This is a 3 dash, and 5, and it is intersecting with 5 dash. 7, it is intersecting with 7 dash here. 7 dash. 4 points I got it. Now let me get another 4. So now, in order to avoid the confusion, I will mark this projection lines into red color. Now let me draw the another line. So that is from 2. From 2 I will draw the projections. So 2 up to 2 I need to draw horizontal line. I will draw first 2 to 8. So draw the horizontal line to these 2 lines. Then from 2 you draw the projection line. So 2 to 2, up to 2 line. So 2 dash, and from 4 up to 4 dash. So till here 4 dash, and 6 up to 6 dash, and then and 7 and 8. So from 8 I need to draw the projection. So 8 to 8. So 8 here. So 8 dash. So now this I got it again another 4 points. So I will trim the extra lines here. I will again use the point mode and point command. I will add the points here wherever there is an intersection. So now I got it another 4 points. So total 8 points. So to avoid the confusion again, I will mark the lines into the red color, all lines into red color. So with this I completed the top base. Let me get the bottom base. This is the bottom base, A, B, C, D, E. So let me draw projections of this the bottom base. Now if I draw the so I will also mark the points later. First I will draw the things and then I will mark the points. So now draw the horizontal projection lines. So till here horizontal projection line, and again from C I will draw horizontal projection lines till here, and then and base will be automatically there. So now again vertical projection line from A. So carefully observe, this is the A. So A dash, and from C and C dash, and E is there. So at the here, so E dash, and then G from G dash, and these 4 points are over. Now I will mark the 4 points. So here point 1, second point, and this is a B, C actually, and E is here. So point E is here, sorry, and G is here. So 4 points I got it. Now I will trim the extra lines which are here. I don't want to use these extra lines. It will confuse the to view the points. So 4 points I received. Now I will again change the properties of these lines to avoid confusion with the projection lines. Then again now I will use another 4 points. Use line command. So from B you draw the projection up to B. Now we need to first draw horizontal projection line, and again from D I will draw horizontal projection line. So now I will use from B draw vertical projection line, and again from D I will draw another vertical projection line up to D. D is still here, and then from F again I can draw vertical projection line. The F is here, so I need to extend this line till some more. So F. Then I need to draw vertical projection line from H. So H is here, so till here. So now I got how many points? So 4 points I got it. So I will extend this line, so till here. So remaining all things are intersecting. So I will trim the other lines which are extra lines. Now I will identify the points. So where is the point A? So this is the B. so B dash, so here is the point B, and a D and a D dash, point D, F and F dash, point F, H and H dash, point H. So I got remaining the 8 points here. So again I will mark this all lines into a red color to avoid confusion with the projection line. Okay, so now I got another points also. So now I need to mark the points. So how to mark the points? Now let me copy the points. So otherwise what I do, first I will draw the line and then I will mark the points so that it will avoid the intersection of the solid line. So how to join this all lines? So now I know that this is the top base, that is 1 2 3, and this all I need to draw with the solid line because this is appearing. So if I join this leftmost corner to rightmost corner, it is almost below, so I need to mark it. So how to join? So here you can use, in the draw command there is a spline. You take a spline fit, so select this, so carefully listen. So you need to draw a spline for 2 times. So now I am starting from this point, so I will just join. This is the first point, second point, third point, like that I will join all the points, and I will come back to this original point and say enter. And this is how actually you can draw the spline. This is one method, and otherwise you can draw again a spline for the next time, so that we can avoid the little error in this the spline. Okay, so this is one way. And now now let me also join the bottom base in the similar manner. So go to spline and again take the same point here, first point, second point, third point, fourth point, like this, and come back to this point and say enter. So this is also another spline. So here this is approximately, it will give almost the similar, there may be little error, because that little error will be eliminated when you take 12 points, but this is almost approximately the good curve. So now I need to join these 2 lines with the line with the tangent. So now I will take a line, and this should make some tangent over here. So I will go to shift right button, go to tangent. So tangent on this line, tangent onto this line. Okay, it is not taking because it is the spline. So now I will take a tangent line. Maybe that is not possible, so let me try again. So let me, it is not showing actually the tangent line onto this. So it is showing here. So you click here, then you go to other, no, off ortho, sorry, I need to off ortho, then only it will show. Now again I need to take a tangent over here. So go to shift button, go to right click tangent. So where it is showing the tangent, you can click there. So here you see whether it is a tangent. So it is not actually proper tangent. You draw this line again. So again you go to line command. So wherever it is intersecting, or otherwise you take from this side now, tangent, the tangent line. So it is not showing the tangent here this side. So go to line command. So take the right button, tangent. It is not taking the tangent, invalid point. So now this is how you can draw, and maybe this you can avoid by drawing another line from maybe somewhere here. We can take on the curve, so maybe like this, but leftmost corner you can go somewhere here, so where it is making tangent approximately you can click over here. So zoom it and click over here. So now you can delete one line which is the inside. You erase. The similar manner you can draw another line here in this side. Go to line command. Again you see where is the tangent, approximately somewhere here. You can click here. So it is only approximation. So now you can go to another line. So you see where it is making a tangent approximately. So you can see here is the tangent it is making approximately. You can draw a line up to here. So now this is the cylinder, final one. So now I need to get the final shape. So this is the final front view. So I wanted to match the properties. This is the final the top view of front view, and these lines are visible. All outside lines will be visible, but here this is not visible. Entire base is not visible. Only half of the base is visible. So till here. So I need to trim this. So I need to mark this the ellipse. So what I do, I will go here, I will trim this line. So if I trim, everything is going off. So better I will trim till here, and here also I will trim half of the line. Then now I will join these two with this the 3-point arc. Go to 3-point arc, first point, and the second point is this, the end point of this line. And another point is this. So again here also I will mark the same manner. One point here, and then next point is this end point. Now I can do trim. So if I do trim here, it will work out. So here also I will work out the trim. So this much accuracy may not be required, but it is necessary. Now let me draw the small arc here, approximately like this. So this point to this point. So approximately it is starting over this point. So this is approximately it is coming from this point to here, this point. Now it is bent, so I will reduce the arc radius. Yes, in that case this is not the tangent. So better I need to make the tangent in such a way that so it becomes a tangent. So this line I need to move further. Point 1 here, point 2 here, and another point is here. So this actually it should not intersect. If suppose if it is if this is the tangent. So let me move. I can move this line also. So select this line, move this point till here, till here. So now this becomes solid line till here, and this I will avoid. So this I will trim. So now I will use 3-point line. I will go back here again. Approximately I will take this point. Okay, now finally what I should do, now I need to make the outside line with a solid line. Finally I need to make this outside line with a solid line, complete solid line, and this should be a hidden line. So the hidden line properties are this. So I need to change the properties of this line also. Even there is a small line here, that also I need to make the hidden line, because this is the hidden line. So here this other half is actually visible, so I need to make the change the properties of this line. Even here also small arc is there, this also I need to change the properties. Now with this I can able to complete the solid projections of solids. So spline, it is actually here it should be appearing like a ellipse, but somewhat it is different shape, but with these 8 points this is only the major accuracy we can able to achieve. Otherwise this seems to be a very small thin line which makes a very good curve here like this. Otherwise it is making another shape. So anyhow, this is one way of drawing, and now I need to give the points, the notations over here. So now I need to give the notations, so I will take the notations 1 2 3 4 from here, and these all things I will mark here. So where is 1 and 1 dash is coming here, and 2 and 2 dash is coming here, so this will become the 2 dash. So you can check here 2 dash. Oh, so 2 dash is somewhere here, this one, and this is 8 dash, so it is coming from 8 dash, so this will become the 2 dash. So now why I have taken these notations, so let me take these notations, because the front view should be denoted with dash. So R prime, so this is 1 prime, this becomes 2 prime approximately here, and 3 will be here, and 4 5, this is a 6 7 8. So now let me move these notations, this actually should be somewhere here. So top base is over bottom base. Now bottom base is A dash, B dash, C dash. So I will copy these notations. So this is A dash. Where is A dash? A dash here. Now because the circumference will have all around, the points will be all around, so I can use the point by point one after the other. So this is a D dash, and this is E dash, F dash, E, F, G, and G dash, H dash. So with this we can able to complete the projections of solids, and this is a question number 4. So I will make the question number 4. So this is the second question, second problem we solved here. So let us save this. Next we will solve sixth problem in the worksheet. Pentagonal prism, base edge 25 mm, height 50 mm, is resting on one of its base corner on VP. Its axis is inclined 30 degrees to VP and 45 degrees to HP. Draw projections of the prism. So now if you see the position of the solid, initially the base corner is resting on VP. So I can keep the solid in this fashion, in the simple position, because the base corner is resting on the VP. This is the vertical plane. So on this the base corner is resting. So whichever the edge and whichever the corner is resting on particular plane, that we will try to keep at the right side so that it will be easy for making the angle. Then this solid is making 30 degrees to VP. So now I need to rotate this solid in such a way that it should make 30 degrees angle with the vertical plane. Then again this same solid is making 45 degrees angle with the vertical horizontal plane. So this is the horizontal plane. Now the axis is parallel to horizontal plane. Now I will rotate such that this will make some angle with the horizontal plane. So this is the final position of the solid, but in this final position I can't solve the problem. So what I do, I will go back to, this is the third step, so I will go back to the second step. So this is the second stage. So in the second stage also I can't draw the front view and top view directly without going to the simple position. So I will make parallel to horizontal plane, parallel to the base, parallel to vertical plane, so that I can able to draw the the front view and top view. Now let us demonstrate these positions of the solids in 3D. Now there are three stages. In the first stage the position of the solid is like this. In the second stage I will be rotating this solid in such a way that it makes 30 degrees angle with the vertical plane, and in the third stage the same solid will be making 45 degrees angle with the horizontal plane. So now if I see the first front view, why I am seeing the front view? Because the base is parallel to the vertical plane. So I will first see the front view. So I will go to the front view and I will see the front view. So now this is the front view. In the front view I can see a regular pentagon, and the base corner which is resting will be on this side. And in the second stage, the position, so this will be the front view, and final position, this is the front view. So in the final position, so this I am rotating, just making some 45 degrees angle with the axis. So this will become the final, the front view. And if I see the top view of these diagrams, so the top view will look like this. So this is the top view, because the base is resting here, and in this second position the base corner is resting, and this is the view 2, and view 3 is just rotating this view 1, and the view 2 rotating, it becomes view 3, and it is resting on its base corner. And by keeping this I will get the final, the top view like this. So let us try to draw the same the projections of the solids in the AutoCAD. So now till now what I did, I have completed 2 problems. Now this will become the 6th problem. So the remaining problems you can able to solve. And now let me just take this the layout. I will copy this layout. So I will keep next to it. So if I am also copying this, because every time I should bring all these notations here, but when you are taking printout, all these things you can able to delete. So now this is not the cylinder, so I will delete this. I will also delete all the front views, top views, etc. Now this is XY line. Now according to the problem, now I will make okay, let me make this little above, because now it should be almost at the middle. It is resting on vertical plane. So now first I should start with the front view, because the base is resting on vertical plane. So to start with, I will take a polygon, and a polygon number of sides are 5, and I am taking the edge, enter, and specify the one end point. So I am just specifying here. So now it is 25 mm. So if you see, it is 25 mm here, 25 mm, 50 mm is the height. Now I will go back here. So I will keep convenient distance with convenient distance, and because it's resting, so it should be, it is resting on vertical plane. So let me little make it down only. because it is resting on vertical plane. So horizontal plane I can make it little above. And this is the corner I am assuming that it is resting on the vertical plane. Now let me draw the projections, because it's the it is a pentagonal prism. It will have the top base and bottom base. Then the height is mentioned here. The height is 50 mm, and here also I can say it is 50 mm. Then I will mention the bottom base. So let us say the bottom base is resting on horizontal plane, vertical plane, and this is the top base. And this we can say this is the vertical edge. Now let me give the notations. So what I do, I can first give the dimension line, projection lines into red color, and I will also change this is the front view and this is the top view. This all are top view, and even there should be a one line here that should be also in the top view. So now I should give the notations. So I will copy the notations from here. So it is like A, B, C, D, and the front view I will take this here. So now let me start with at this point. So I will move. So this is A dash 1 dash, and this is B dash 2 dash, this is C dash 3 dash, 4 dash, D dash, E dash, and I will be taking the bottom view as ABCD and top view as top base as 1 2 3 4. So now let me give the notations here. So again I will take the notations here from here, but now it is actually top base and bottom base is different. So I will take these notations. So now this will become now this I am assuming that this is the top base, so I will be writing 1 2 3. So I will be moving these notations. So this becomes a 1 as well as 2 and 2, and this becomes a 3, this becomes a 4 because 3 and 4, and 5 will be here, again coming back here. Now again A, B, C, D, and A and B here, and B over here, and this is C, and D is this, and E will be next to C. So this I don't require. So now this is the, and let me draw axis also. So I will draw axis from the center, and this is the center of the solid. So match the properties. So this is the axis. Where is the axis? This is the axis. Axis you can see the height, and this is the projection line. So this is the projection line. This is the projection line. Now I will give the dimensions. So go to dimensions. This base edge length is mentioned. So base edge length is 25, and height is mentioned 50, and these two the details I will give here. And now, and I am assuming that this edge is resting on vertical plane. Now I will make angle with the vertical plane. So vertical plane means with respect to XY line, and this point should also rest on XY line. So what I do, I will copy this, because there is no hidden lines here, because this hidden line is coinciding with the visible line. So I will copy this, and I will be copying somewhere here with the convenient distance. It is not showing the nearest point. So nearest point it is not showing, intersection point, node point nearest point it is not showing, so I will be taking the some nearest point somewhere here. So actually this nearest point not required every time, that is why we just off it. So now I will rotate this. So rotate this top view and such that this should make 30 degrees angle with the vertical plane. Is it correct? So 30 degrees angle with the vertical plane. So now 30 degrees means already it is making 90 degrees, so I need to rotate this to 60 degrees. Now if I draw here only, so there won't be any space for the final top view, so I will be moving this somewhat the left side. So I will move till here. Now it is showing this point. To avoid this, what I can do, I will select this and I will on ortho, I will move parallelly like this, so with some convenient distance. So this will be the convenient distance. Now this will be the third view, and third view is over. Now I need to get the view 4. So in this view 4, let me draw the projections. Horizontal line, line of projection lines. This is the projection lines. Now this, let me also draw the projection lines from 1 to 1 and 4. So now let me draw the let us say top base. Top base I am always calling as 1 2 3. So let me draw the projection from 1 2 3 4 5. So if I draw the projection from 1 to 1 dash, so 1 to 1 dash till here, and 2 to again 2 dash, it is already coinciding. From 3 to 3 dash up to 5, 3 to 5 dash, and 4 to 4 dash, 4 to 4 dash. Where is 4 dash? 4 dash is here. So with this I can able to the trim other lines which are not required actually this much projections. So I can even trim this. I can even trim this. So now let me the point, mark the point. So this is 1 and 1 dash, there is a point, and there is the 2 and 2 dash, there is a point, 4 and 4 dash, there is a point, 5 and 5 dash, there is a point, 3 and 3 dash, there is a point. So there are 5 points. So apart from that, remaining lines not required. I will just the trim these lines. Now I can able to understand how the projection lines are actually coinciding or identifying the required points. Now when I see the front view from this side, so if I draw a imaginary line from leftmost corner to rightmost corner, I can able to see this surface, this the top base, because I am seeing from the front. So this I can able to see, and other side of the line I can't see. So now I can able to see this line. So let me draw this the top base. So by taking a line command, so draw a line from here to here, and all these points you can connect. So this becomes the top base. Now let me also identify the bottom base points. So take A from A to A dash, and D to D dash, D to D dash, and then C to the E to E dash. I can and mark the points. Take a point command. So take point here, here A, B, and C is here. So C and C dash, C and D dash is here, and E and E dash is here. Now if I see, now I need to identify the hidden lines. So before that, what I will do, I will first mark the outside lines. So first let me draw outside lines. Outside lines will not be any the hidden lines. So I will draw outside lines. So these are the outside lines. So now let me also draw the projection lines into the white color. So now these are the outside lines. Let me also make the dark. So this is the front view. So these all lines should be dark. these all are visible. So now if you let me also give the notations like the front view A, B, C, D, A dash, B dash, C dash. So let me bring this notations here. So when I give the notation, I will delete this. So this is the top base. The top base. So let me start with 1. So I will move this. So this is 1 dash. Here is the 2 dash, 3 dash, 4 dash, and 5 dash. And A dash is this A dash. So sorry, this one is A dash. This is B dash. C dash, and this is a D dash, and E dash. So these are the points. So let me also move A little away from here. So now these points not required. So now I given the notations. Now I should also draw axis line if required, otherwise not required. But axis line also visible now. So I can even draw axis line from here to here. So this line should not be visible then. So I will trim this. I can extend this, it becomes another line, and here also I will trim. So this is the, so let me match the properties of the axis line. So this is the axis line, and these are the projection lines. Then so this is the top base. I can able to see all outside lines are visible. So now how to identify the hidden lines? So I given one concept. You draw a line, imaginary line. Let me draw. I will delete later. This should not be there. If I draw a imaginary line, so whatever is there, whatever the edges are this side, all are visible, and whatever is not there, that will be visible. So because the top base is the below this line, because I need to see the front view, so this is visible, so I draw this dark. And also all the outside lines will be visible, no hidden lines will be at the boundary. So that's why I made everything the bold or the solid line. So now whatever is other side of the line, so will not be visible. So what are the other side of the line? And if you see BC is other side, but it is outside the boundary, so it will be visible. So then the CD, C and D is the side, so CD is not visible, and D, E also this side, so this also will not be visible. So let me draw these lines. So this is not visible, and this is also not visible. And again there is another edge, that is D4. D4 also will not be visible. So now I will be drawing another line from here to here. So at that time this axis line will go. So this axis line will be eliminating. So I can even need to delete otherwise. So I will be extending this up to here, because the axis line is coinciding with the hidden line. So at that time I need to use only the dotted line, hidden line. So now these three are the hidden lines which will not be visible in the front view. So now let me change the properties of this. So these lines, hidden lines, so change the properties of these three lines which are invisible. So now this will be the fourth view, and that is the fourth view. Let us actually now the axis is making 0 degrees or the parallel to horizontal plane, but now I need to rotate in such a way that the axis will make 45 degrees angle with the horizontal plane. So now let me copy this. So I will copy this front view. The fourth view I will copy and I will rotate. I need to rotate. I will rotate. So I will rotate to 45 degrees. So rotate the front view to 45 degrees angle. So 45. Now you can move the view suitably. So move the view, the full view. I can also move the view little near to the view 4, then it will be within XY line. So this point is missing, so this should be somewhere here. So this point is also important sometime. So now something is missing, so these lines are visible. So these lines are visible, that is A1 and AB2 are below this line. So this I forgot to draw. So these lines are visible. These lines are visible. So I need to join this. So mark the properties, match the properties of these lines. Sorry. So here also I need to mark the lines because these vertical edges are missing here. I can able to clearly see. So match the properties of these two lines. So now I need to get the final top view. So to get the final top view, I will be drawing the projection lines. So from where this line, this is the imaginary line, I am actually deleting. Now I need to draw the vertical projection line or otherwise horizontal projection lines. So let me draw the projection lines from each and every point. So first I will be using the top base. So top base points, and these are the top base points 1 2 3 4 5 6. So these are the top base, and this is axis. Axis I will draw later. And let me draw the vertical projection line. So from each point, from 1 up to 1, projection line you draw up to the corresponding line only. So 2 to 2 dash, 2 dash to 3 dash to 3, 3 dash to 3 up to here, and 4 dash to up to 4, and 5 dash to up to 5. So now you mark the points. So wherever there is a intersection, there you can mark. So take a point command. So this is 1 dash, 2 dash, 3 dash, 4 dash, and 5 dash. So these are the 5 points, we got it. But when you are seeing if you draw a leftmost corner to rightmost corner, this is above the line. So now let me draw another imaginary line from leftmost corner to the rightmost corner. So this base is above this line, so it will be visible. So let me make this dark. So let me draw a line from here to here, and here to there to here. So this is the final the top base. So let me match the properties of this line to avoid the confusion, and also draw the trim the line points or the lines till the point to avoid the confusion. So this is the top base. So the top base also you match the properties of this top base, so it is visible, so you make it dark. So let me also draw the projections of the bottom base. So draw the projection lines from A up to A. So A, B, C, D is not here, so let me draw the projection line from here. A, this is A, is only A and B. So till here I draw, and this is D is here, and C and E I will be drawing till here. So draw the vertical projection line from A to A, and B to A, B, and C to C. Where is C? C is here, carefully, and E to E, carefully, and D to D. So now mark the points. So this is the A, B, and this is the C, D and E. So now I can mark, but some of the hidden lines are there, so I will not mark, but I will just mark the notations. So before that I will also trim extra lines, so like that. So now let me draw let me give the notations. This is the top base, so it will be 1 2 3 and A B C D up to 5. So I will be keeping the notations here. So now let me start with the 1 2 3. So 1 2 3, so it is starting here. So let me move. So this is 1, this is a 0.2, 0.3, 0.4, 0.5, and then here A B C D. So where is A and A dash? A is here. So A I will keep here. The B is here. So let me keep the B here. And C is this place. I will keep near to that point. And D is this place. Or D is this place, sorry, this point is wrongly placed here. So D is this, so point should be here, and D, this is the D, and which is resting on horizontal plane, and this is a E, and this is E. So I will keep somewhere near to this point here. Now if I carefully observe, so now I will this imaginary line I can delete, but I wanted to first make the dark line all the outside lines. So outside lines here is 4D, 4 and D. This is 4 and D. D is here. 4 and D is outside now, because in the top view 4 and D is outside. So I will dark this. So I will draw a line from 4 to D, and then 4 to D over. So then 4 to E, D to E. D, where is D? D is here, and from D to E, which is also outside. So this is also outside, because no other point is outside this line. So I can draw another line from D to E, and then D to E to A. E to A also outside, so I can draw another line from E to A, because it is outside boundary. Then A to 1, A to 1, A to 1. It is also above, but A to 1 also I can draw a solid line. So these all are outside lines. I can make it dark. So now if I take match properties, these all are outside, so I will make it dark. So match the properties of this line. So these all dark lines. Then 5 to E. 5 to E, where is 5 to E? And E is here. 5 to E is above this line, so it is the solid line. So I will draw a line which is solid and match the properties, this to here. So now with this all the visible lines are darkened. Now let me go to the invisible lines. And invisible lines are the below this line, and BC, especially BC is the invisible line. This is away from this point, this line. So draw a line from B to C, and B to C is over. And if you observe C3 also, C and 3 also invisible line. So draw a line from C to 3, and again from B to 2 also invisible line. B to 2 also invisible line. A to B also invisible line. A to B also invisible line. So here to here is invisible line. So now with this, and again C to D also invisible line. So these are the invisible lines. Let me match the properties of projection line. These all are projection lines. This is also projection line, this is also projection line. To avoid the confusion of these lines, all are in white color, so I made it these all projection lines into red color. So then remaining lines are invisible lines. Let me match the properties of blue color. It shows the invisible line. This is also invisible line, invisible line, invisible line. This is invisible line. So here there is a small line, red color, so let me also trim this line. Oh sorry, so let me draw a line. It is invisible line. So match the properties of this line to this. So with this we completed the final view, and in this view we can able to see this the top view like this. Final top view will be looking like this. So with this we have completed the projections of solids, the problem. So this is the problem number 6. So this way we can able to draw the projections of the solids when they are inclined to both the planes. So sometimes here I did not mention the angle, so you can also mention the angle. So you can give the angle. So here the angle is 30 degrees, so you can give angle between these two, so conveniently somewhere without intersecting the lines. And this also 45 degrees angle. So this 45 degrees angle you can give with this edge also, this edge with XY line. So yeah, this is 45 degrees. And here also I missed the angles, and you can give the angles. And here axis I forgot, and you can avoid it. Sometimes the axis will confuse the things, so we can. And this line I need to delete, because this is the imaginary line I have drawn only to see how the hidden line and visible lines are appearing. So here in this way we can complete the projections of solids. How to take printout of this? So it is very simple. So you select all these things. So let me first save these diagrams. So select all these things, all this layout, and because with different color codings we have used, so make everything white. So go to properties, or write quick properties, and you change the entire thing. Go to, maybe instead of quick properties, go to properties, change the color. Color is varying, but you can make everything white. You can make everything white. Escape. But dimensions color will not be changing, so let it be, no problem. So now you can take the printout of this. So you can go to Control P, and we can go to the previous plot we already plotted. So here you use ISO full blade A4 and drawing to PDF. So select the window. So I wanted to print this, so select from this corner to this corner, and go to the scale, don't fit to paper, scale 1:1, go to preview. So now you can able to see exactly how we draw now. So we draw with the different color codings, but these color codes will not be visible now, because we made everything black and white. So now if you take all thin lines and thick lines, dimensions, everything are visible clearly, and even after taking printout, this will look like with the same manner. Thank you.